So today we'll be talking about current and also more specifically household circuits, how the circuits in your house work. So remember that electricity is just flowing electrons. Right? When you go and switch a light switch on, you're allowing electrons to move down that wire and you're creating a complete circuit that electrons can move in. Now, the first word here that we're going to talk about is current. And current is the number of electrons that flow down the wire. And we measure it in something called amps. All right, so let's give you an idea of what some examples would be here. So if you have a phone charger, it doesn't use very much electricity. A phone charger would use about 0.5 amps. That's just the amount, it's a way of describing the amount of electrons that are flowing through the wires in your house and through your phone charger in order to make it work. Something like a toaster uses a bit more electricity. It would use about 9 amps. Right? It actually needs to heat up those filaments inside of your toaster in order to toast your bread, so it needs quite a bit more electricity. It uses about 9 amps of electrons flowing through that wire. And a stove needs to use even more, right? You have multiple elements, you have the inside part. A stove, it usually uses somewhere around 35 amps. Now, when we're dealing with electricity in a house, there's also some safety aspects we need to look at. If you have too much current flowing in a wire, if you have too many electrons flowing down a wire, it actually begins to heat up. Those electrons will bump into each other, they'll lose some of their energy to heat, and that wire will get warmer and warmer. So if you have 0.5 amps or 9 amps going down a wire in your house, it's totally fine, right? They don't get very warm, it's not a concern. The wires in your house, they're designed to handle about 15 amps. And once you get more than that much power going down them, they'll start to become warm and they'll become a fire hazard. So for example, even just plugging 2 toasters into the same circuit and running them, that would actually be too much. The wires would start to get too hot. You could plug them into different circuits in your house, but if you plug them into the same circuit, it would actually be too much for that circuit to handle. So current is just measuring how many electrons are flowing in the wire. And also how much electricity you're using. All right, so a box like this, I don't know if anyone's seen one of those in their house before. You'll find one of them in every house or every apartment, every office building, anywhere that has electricity. So this box, it's usually found in the basement somewhere. Sometimes it's behind kind of a panel or something. This thing here is called a breaker box. And this is where electricity enters your house. So there's a big main cable that's coming in, usually the top or the back of it, and it's carrying all of the electricity, all of the electrons that are coming into your house. So, and also, all of the individual electric circuits in your house will go through your box, and each one of these switches is for a different circuit. So each one of these switches, they're usually labeled. So I think this one has a little diagram on the sign that's labeled. Sometimes people put little stickers beside them and write down what each one goes to. But each one of these switches is a separate circuit. It takes power from the main, and then it goes out into different circuits in your houses. So for example, this one might go to run your stove. This one might be going to run your air conditioner. This one might be going to run, that's a double one. Oh. This one here might be for your fridge. This might be for your lights in your kitchen, the lights in your living room, the plugs in your living room, the plugs in your kitchen. So each one is a separate circuit. It's typical that there's at least this many in a house. Now, each one of these switches, it's a special type of switch. It's called a breaker. And these are special types of switches because if the current is too high, right, if you plug in 2 toasters into the same circuit, if they get too high, these switches they'll heat up, right? The wire will start to heat up and this switch will start to heat up. And when they get hot, they actually automatically switch off. So that's a safety mechanism. It's called tripping the breaker. So in this case, instead of the wires getting so hot that they start a fire, as soon as they start to warm up, this switch also warms up and it automatically turns itself off. And now if you go and try and use that plug, it just doesn't work. So for example, if you plugged too many appliances into the same circuit, so maybe you plug a toaster and a kettle on and you turn them both on at the same time. It's okay if they're just plugged in because they don't pull any electricity until you start using them. But if you turned on your toaster and your kettle and they were plugged into the same circuit, then it might cause the breaker to trip, right? It might cause too many electrons to be pulled, too big of a current. It heats up and that breaker warms up and switches off. In this case, it's okay. It's not a big deal. You would just make sure that you go and you unplug some of those appliances. So maybe go and unplug them and only use them one at a time. Wait about 5-10 minutes in order for that breaker to cool down, and then you go and you just switch it back on. Right? These things are reusable. So if they trip, it's okay. Just let them cool down, turn them back on. If it keeps tripping over and over, well, then you have a problem. You need to figure out what's causing that, right? And if you try unplugging things and it's still tripping, then you would need to call an electrician. Now you'll notice there's a large switch at the very top. I'll go up to it again here. So in this case, a giant switch at the top. Sometimes it's somewhere else. Sometimes it's at the bottom or in the middle. But there's usually one giant switch, and that's called the main. That's where all of the power comes through. So the switch at the top is called the main, and if you were to turn that off, it turns off all the power to your house. So if there was, for example, a gas leak in your house, and you needed to make sure that there was no power that might cause a spark and an explosion, you could easily turn off all the power to your house. You would just switch that one main switch off. Here's a picture of another circuit breaker, and once again, there's that giant main switch. Now, we said earlier that most household circuits can handle about 15 amps, but some appliances like your stove require a lot more. They use like 35 amps. So in that case, you'll notice that there's actually special circuits and special breakers for those appliances. So for example, looking at this breaker box here are my regular 15 amp circuits. These just use regular wires in the walls. That one's for the kitchen plugs, living room plugs, kitchen lights, living room lights, bedroom plugs, right? One for kind of each circuit in my house, one for the washing machine, for the dishwasher, outside lights, bathroom, bedroom. And then there's these double ones. So these breakers are twice as big. And the wires in your walls that are connected to these breakers are also much bigger. And that's because these breakers and these wires are designed for appliances that pull a lot more power, that pull a lot more current. So for example, here's one that goes to your stove. So those wires can often handle up to 40, 50 amps. And here's another one that's set up to go to your dryer, because that one is also a high current appliance. And there's actually special plugs. So behind your stove and behind your dryer, they actually use special plugs like these, and these things are designed for higher power. They're designed for 35 amps if they need to. Now I made kind of a short demo video that you can watch next where I went through and actually showed you the breaker box in my house and kind of described a bit more in detail. So you're welcome to watch that to get a bit more information on that. Generally with your breaker box, if you wanted to permanently turn something off, right? So for example, maybe your air conditioner in the winter, you could go and switch it off. You can manually turn them off if you wanted to make sure that it doesn't turn on. Other than that, if they are tripped, you would just wait 10 minutes for it to cool down, and then you could turn it back on yourself. All right, different types of outlets around your house. All right, so the ones that you're probably familiar with are these ones here. These are called 3-prong outlets. And any new homes, or really any homes that are built in the last 20 years, will have those types of outlets there. They're now required. And that's because the 3rd prong here, the kind of half moon one, that's called a grounding plug. And you'll notice the older ones, if you go into an older house, sometimes they don't have it. It's just the 2 prongs. What this grounding plug does is it actually connects back to your breaker box, and your breaker box connects to ground. And that's because electricity always wants to go back to ground if it can. It wants to go to a big object that it can lose the electrons to. So if there was some sort of short circuit, instead of the electricity going through the appliance, so for example, let's say I had a lamp that was plugged in here, instead of the electrons finding a way through the lamp or through a person to get to ground, instead they would follow this grounding plug. Okay, so what this grounding plug does is it makes it much less likely that someone will be electrocuted by accident. Okay, because that grounding part, it touches all of the metal parts on the lamp. That's what this wire is connected to. So if there was any sort of short circuit, it would try and go through this plug instead of going through, for example, a person. Sometimes you'll notice people will they'll take an extension cord and if this is the only type of plug they have, they'll cut off that grounding plug, and that's a really bad idea, right? That grounding plug is there as a safety mechanism, and it's to make sure that someone doesn't get electrocuted. So you certainly should not be removing the grounding plug. It's there for a reason, right? If you can't plug it in, then in this case they probably need to call an electrician and maybe update some of their electrical work in their house. Right, so that guy there is the grounding plug. Now, not all appliances have them. Sometimes if something doesn't pull a lot of current, so for example, a small lamp or something, they won't have them. But generally, they are a good idea, and we're seeing more and more appliances will have that grounding plug on them. Now, you'll notice if you look at the outlet that's in your bathroom, it actually looks a little bit different. It has these 2 little switches here, 2 little buttons. So bathroom plugs have a special type of breaker, and it's called a ground fault interrupter, or GFI. And what it's used for, you can tell it has it because it has the 2 little buttons there. The reason it has those is that there is a lot of water in a bathroom, right? Whether it's the sink or the bathtub, and water, at least tap water, can conduct electricity. So if water is accidentally splashed onto the plug or onto an appliance that's plugged into it, so for example, let's say you had a blow dryer that was plugged into that outlet and it accidentally falls into your sink while you're washing your hands. That's a major problem because the electricity, it might flow through the water, might flow through you in order to get to ground. It might electrocute you. So in this case, anytime you have water around electricity or around an appliance that you're using, it's automatically a bit more dangerous, right? So they install these special types of breakers called GFIs. If the electricity does start flowing through water or through a person, the GFI will automatically sense that. It will sense that more electrons are flowing, and it will automatically shut off the circuit. So it's actually a special type of breaker that's designed for when there's some sort of short circuit through water or through a person.